Hello students, lesson number 5, quadrilaterals. Under this yesterday I told you to write the proof for the following statements. Some students wrote the proofs and sent it to me, and some students sent. So remaining students complete their proofs and send me on my personal number. So in till now we studied the properties of the rectangle, and we will remember it at first, and then we will start the next part, that is the so here it is the rectangle, and we are studying the properties of rectangle. So here first property is the diagonals of a rectangle are congruent. Suppose this is our rectangle ABC, and here it is D. Okay, so here it is rectangle ABCD, and its diagonals, that is AC, that is AC, and BD are the rectangles. AC and BD are rectangle, and we seen the first property, that is the diagonals of rectangle, that is AC is congruent to what? BD. AC is congruent to BD. Secondly, diagonals of square are also congruent. If you see here the figure, the diagonals of square are also congruent. If you see, so that also we had seen, if it is a square, its diagonals means here also AC and the AB only we will take as per the names. So they are also congruent, that is A, B, C, D. Then AC is congruent to what? BD. Then next property is the diagonals of rhombus are perpendicular bisectors of each other. So rhombus also we know how is the figure of rhombus. So diagonals of this rhombus are also congruent. So here it is a rhombus, and its diagonals are also congruent to each other. Diagonals of rhombus are also congruent to each other, means here also AB is congruent. If we give the name to this figure, that is A, B, C, D, here also AC is congruent to AD, BD, and they are perpendicular bisector, means AO is perpendicular on BD, same way BDO is perpendicular on AC. So the diagonals of rhombus are perpendicular bisectors of each other. These points are important, that's why I am going to repeat. I am repeating this because this we have to write as a reason whenever we are solving the theorems. Okay, after this, the diagonals of rhombus bisect the pair of opposite angles. Means suppose this is a diagonal, this is our rhombus, its name is A, B, C, D, and here it is O, and then this diagonals means AC and BD bisect the opposite angles, means they bisect DAC, means this angle and this angle is congruent to each other, means these are angles, means ADB is congruent to CDB, then DCBA is congruent to ACB, CBD is congruent to DBA. In that way they bisect the opposite angles. Next, the diagonals of square are perpendicular bisectors of each other. Okay, so for the square also, suppose this is our square. Okay, so its diagonals are perpendicular, means here it is perpendicular, means they intersect each other at 90 degree, and bisector means suppose this is A, B, C and D, then AO is equal to OC and OD is equals to OB, OB is equal to OD. Okay, and here angle AOD, angle DOC, angle COD, B and BOA, all right angle. Okay, and the last, the diagonals of square bisect opposite angles, means here opposite angles also what they are bisect the opposite, means this AC means DAC is congruent to C8B, ABD is congruent to DBC. In that way, all angles, what happens, this AC angle bisectors also. After this, you have to solve this practice set number 5.3. So, by using these properties, we have to solve the practice set number 5.3. Okay, then so easy it is actually. The diagonals of rectangle ABCD intersect at point O AC. So if for this, if you draw the figure, then the solving of this example, it becomes easy for you. Okay, so here it is ABCD. Okay, and diagonals intersect at point O, they told you. So here it is point O, A, B, C and D. Now here AC is equal to 8 given. So AC is 8, then AO is equal to 4, OC is equal to 4. Then find BO and BO. So BO is equals to how much it is there? 4, because they are congruent. AC is congruent to BD, and BO and OD, they are equal because they are bisect, diagonals of rectangle bisect each other. And angle ACB we have to find out. So measure of angle ACB is equal to 45, because rectangles, all angles are 90 degree. In this way, if you draw the figure, you will get the answers and use these properties for that purpose. Now here, in that way, you just solve the question number 2, 3, 4. Okay, and here a true false statement is there that you have to solve. Now the next we will see the trapezium's properties. Okay, so what are the trapezium? When one and only one pair of opposite side of quadrilateral is parallel, means AB is parallel to DC. What I said, AB is parallel to DC, then quadrilateral is called as a trapezium. Okay, this is the trapezium. Otherwise, this is also the trapezium. Now I drawn the figure that. Okay, so here these are called as a trapezium, and the trapezium's property is that its opposite sides are what? Its one pair of opposite side is parallel to each other. Next, in the adjacent figure, only side AB and DC of quadrilateral ABCD are parallel. Okay, and parallel to each other. So this trapezium, angle A and angle D, these two are the what? Supplementary, because if AB and DC are the parallel lines and AD is its transversal, then BAD and ADC are interior angles between two parallel lines. And as we know that the sum of interior angles of angles between parallel lines is equals to how much? It is 180 degree. So angle A plus angle D is equals to how much? 180 degree. And same way, angle B plus angle C, B plus C is equals to 180. This is the property of trapezium. Now here non-parallel sides of trapezium are congruent, then this is called as a isosceles trapezium. Just I shown you one figure, that is, this is also a parallelogram, because here two lines are parallel to each other. Okay, this is also parallelogram, and sometimes these two sides are not parallel to each other. It is like that and it is like that. So these are not congruent to each other. And here, if it is congruent, means PS is congruent to QR and PQ is parallel to SR. PQ is parallel to SR and PS is congruent to QR, then the given trapezium is called as isosceles trapezium. It is called as a isosceles trapezium. The segment joining Midpoints of non-parallel sides, the segment joining midpoints of non-parallel lines sides of a trapezium are called as its median of trapezium. Now if you see here, the segment joining midpoints of non-parallel sides, suppose PS and QR, these are the non-parallel sides, and here point L is there, suppose, or M is there, point M, and here it is point N, and this line means these are the midpoints, and line which joins the M and N. M and N means the midpoints of the non-parallel lines joined by a segment, then this MN is called as its a median. Okay, how triangle has median, opposite side and vertex, midpoint of opposite side and opposite vertex joined by a segment, then that segment is called as its a median. So in that way, MN is the median in this figure. So now we will see the examples based on these properties of trapezium. And the first example is measures of angles of quadrilateral ABCD are 4:5:7:8. Show that quadrilateral ABCD is a trapezium. As we know that sum of all angles of a trapezium is equals to how much? It is their trapezium or any kind of quadrilateral. Sum of all angles of a quadrilateral or sum of all angles of trapezium is equal to how much? It is there. It is 360 degree. And if here ratio is given, so if ratio is given, we have to take the x as a variable with them. So here we have to write, let the measures of angle A, B, C, D are with this 4x, 5x, 7x and 8x. So in this way we have to write its measure. Let the measures of angle A, B, C, D are 4x, 5x, 7x and 8x respectively. Okay. Then sum of all angles of quadrilateral is equal to 360, that we know. Now here what we have to do, write measures of all angles, that is 4x plus 5x plus 7x plus 8x is equal to 360. Sum of 4x, 5x, 7x and 8x is 24x is equal to 360. And if you divide this 360 with the 24, you will get measure of x is equals to 15. And it is the common variable for this. So 4x is equal to, angle A is equal to 4x is equal to 4 into 15 is equal to 60. Angle B is equals to 5x. So if angle B is equal to 5x. So the measure of angle B is equal to 5 into 15 is equals to 5 15 7s are 15 5s are 75. Angle C is equal to 7x. So C is equal to 7 into 15. So 15 7s are 105. And at last angle D is equals to 8 into 8x and 8 into 15 is equal to 120 degree. Afterwards, here next question is the show that the given it is the parallel trapezium, sorry. So trapezium, if I have to show, you have to show that sum of angle CDA and DAB is equal to 180. Otherwise angle DCB and CBA, these two angles measure 180 degree. So for that, here we will see the opposite angle sum is, so here it is angle D plus angle angle D plus angle A, otherwise angle B plus angle A, any two angles, because this we have to show as A plus B is not equals to 180, we have to show, and D plus A is equal to 180. If we show, then it is possible to means it is a trapezium. So here they show CD is parallel to BA. CD is parallel to BA because sum of these angles, which angle D and angle A is equal to 180 degree. See here, B plus C, otherwise D plus A is equals to 75 plus 105 is equal to 180, and A plus 180 degree it is, and angle A plus D, angle A plus D, if you see here 60 plus 120 is equals to also 180. So DC is parallel to AB. And second, we have to show that angle A plus B is not equals to 180. So angle A is equal to 60 and angle B is equal to 75. So angle A plus B is equal to 135 and it is not equals to 0. Means from this what we are understanding, here it is one only pair it is there in this figure which is parallel to each other, DC and AB. Okay, so here we have to write side DC and AD are not parallel and therefore quadrilateral ABCD is a trapezium. So in this way we are going to prove that ABCD is a trapezium by using this property. And next it is the proof is there, it is bigger one. So this example we will take in our next lecture and then you have to solve 5.4. Okay, actually it is very easy lesson from our syllabus. Okay, so all of you complete today's, that is 5.3 2 you 5.2 you have completed, 5.3 you have to complete today. Okay, so today we will stop here only. Okay, thank you and have a good day.